Throughout history, humans have gazed at the sky, marveling at the stars and the vastness of the universe. They have pondered the nature of their world, questioning what lies beyond the horizon and the mysteries of the cosmos. The idea of a flat Earth has persisted for centuries, deeply rooted in ancient civilizations and their interpretations of the world. It's a simple, intuitive concept that aligns with our everyday experience, where the ground beneath our feet appears flat and unending. After all, when we walk on the ground, it seems flat and solid, giving us a sense of stability and certainty. The horizon, whether at sea or in a vast desert, seems to stretch out endlessly before us, reinforcing this perception. However, appearances can be deceiving, and what seems obvious isn't always the truth. Scientific inquiry, through rigorous research and exploration, has provided overwhelming evidence that Earth is not flat, but rather an oblate spheroid, a sphere that is slightly flattened at the poles and bulging at the equator, a shape confirmed by satellite imagery and space exploration. The allure of a flat Earth persists despite the scientific evidence, perhaps fueled by a distrust of authority, a desire for simple explanations in a complex world, or a yearning for a sense of control in an unpredictable universe. One of the most fundamental forces in the universe, gravity, would behave very differently on a flat Earth. Gravity, as we understand it, is a force that pulls objects towards the center of mass. This force is what keeps us grounded and dictates the motion of celestial bodies. Gravity pulls everything towards the center of mass. On our spherical Earth, this means that gravity pulls everything towards the center of the planet, regardless of location. This uniform pull is what gives us the sensation of weight and keeps our feet firmly planted on the ground. On a spherical Earth, this means that gravity pulls everything towards the center of the planet, regardless of location. This is why objects fall straight down and why people all over the world experience gravity similarly. No matter where you are on the globe, gravity acts in a consistent manner. This is why objects fall straight down and why people all over the world experience gravity similarly. The force of gravity is what allows us to walk, jump, and move without floating away into space. It's a constant force that acts uniformly across the entire surface of the Earth. On a flat Earth, however, the center of mass would be at the center of the disk. This would lead to some strange gravitational effects. Instead of pulling straight down, gravity would pull towards the center of the disk, creating a very different experience of weight and balance. This would lead to some strange gravitational effects. The further you traveled from the center of the disk, the more gravity would pull you horizontally towards the center. This would make walking and moving around quite disorienting and challenging. The further you traveled from the center of the disk, the more gravity would pull you horizontally towards the center. This horizontal pull would become stronger as you moved towards the edge, making it feel as if you were constantly walking uphill. Such a scenario would drastically alter our daily lives and the way we interact with our environment. The Earth's tilt on its axis is what gives us our seasons. This tilt causes different parts of the Earth to receive varying amounts of sunlight throughout the year. As Earth orbits the Sun, the angle of sunlight changes, leading to the progression of seasons. Different hemispheres receive varying amounts of direct sunlight throughout the year, creating the familiar pattern of spring, summer, autumn, and winter. This intricate balance wouldn't work on a flat Earth. The concept of seasons as we know them would be impossible. It's difficult to even imagine how a flat Earth would interact with the Sun. The dynamics of sunlight distribution would be entirely different. Would the Sun hover above the disk, moving around like a lamp on a table? This raises more questions than it answers. If so, how would day and night work? What about the seasons? The natural cycles we observe would be disrupted. A flat Earth model simply cannot account for these observed phenomena. The round Earth model explains the changing seasons and the cycle of day and night perfectly. Navigation would be a nightmare on a flat Earth. On our spherical Earth, we use latitude and longitude to pinpoint locations. This system is based on the Earth's axis of rotation and the equator. On a flat Earth, these concepts would be meaningless. How would you determine your east-west position on a disk without any points of reference? Travel would be incredibly difficult, if not impossible. Exploration and trade, as we know them, would cease to exist. the world would be a much smaller, more isolated place.